Welcome to Chapter 8, Section 1 on 3 different types of variation. Very simple equations where we have some number, some constant, we'll call it k, some magical number where you take it times, either times x, or you'll either take it and divide it by x. For direct variation, we simply take k times x, and you'll say, okay, looks like slope, and then our y-intercept is 0. Which is basically what the deal is. This represents a direct relationship, whereas something gets bigger, as I go to the right, I also might go up. That's a direct relationship. Go right, go up. They're both heading in a positive direction. Direct simply means multiply. So here's an example. If you see direct, you need to be thinking multiply. And when you see varies, I want you to think equals k. So I've got force varies directly. So I'm going to multiply with acceleration. Right equation that represents a statement. Well, there it is. Force equals k times a. I ask a scientist, what does the constant k stand for? Well, force equals mass times acceleration. So k in this case would be whatever the mass was you're dealing with. Main thing is varies is equals k, direct is multiply. How can you tell if points represent direct variation? Well, it's y equals k over x, which leads me to k equals y over x. You're basically finding slope. So if you've got a set of points, and for every case, y divided by x is the same, it's direct. So let's say I had 210. That y over x would give me a k of 5. So no matter what else I put here for points, when I divide y by x, I have to get 5 for it to be a direct relationship. So if I put a 5 here, this would have to be 25, because 25 divided by 5 is 5. If I put a 40 here, this would have to be 8, because 40 divided by 5 is 8. So when you've got that, you've got a bunch of points where when the quotient of y and x is the same, it's a direct relationship. On your assignment, you've got simple problems like this, where they give you a pair of coordinates, 3, 6, tell you it's a direct relationship, so it's y equals kx, and then you're supposed to figure out what k is. Well, you could write it like this every time. Find k is 2. Or you could just say, all right, he told me y divided by x is k, so I can see it's 2 right away. So the equation we're going to use is y equals 2x. And then now I've got to follow up. If x is 10, what's y is what I'm basically asking. 2 times 10 is 20. So that would be the follow-up part to it. Part B, maybe you should try that. Pause, see how you did. Part B, y equals kx. Well, y divided by x gives me k. So that's a half. That leads me to y equals a half x. And on this one, I'm giving you y. So you actually have to multiply by 2 and find out that x would be 18. So 8 goes to 18, as 4 goes to 9. That's a direct relationship. The 8's getting bigger to 18, the 4's getting bigger to 9. Both getting bigger by a factor of 2 1/4. The next type is inverse variation, and that's when you take this magical number k and divide by x. If you divide k by x, that means that to find k, you would simply take y times x, or x times y. So if I gave you a set of numbers over here and said, are they inversely proportional, or do they vary inversely? A couple different ways to say that. You would have to say that, well, let's say I got 6 and 4 here. They make 24 if I multiply them. So it represents inverse variation as long as what I put here equals 24 when I multiply them. 3 times 8 is 24. If I put a 12 here, I need to have a 2 here, because 12 times 2 is 24. If I put a 1 here, I'd have to have a 24 here, because 24 times 1 is 24. So part of your assignment, simply to do what I just did over here, is to identify if it's inverse, direct, or neither. Inverse, they have to multiply to be the same. Direct, you go y over x, and those would have to be the same. And then neither if neither one of those apply. Example 3. The volume of a gas varies. So I'm going to put V equals K. And it says inversely, so let's divide by P. Volume equals K over P. The volume is 240 with a pressure of 30. Then we want to find what the pressure would have to be to have a volume of 160. What's going on here is I'm trying to make a volume smaller. So let's pretend I got this gas and it's in a bubble, and this bubble's got a certain volume. What would I have to do to make the volume smaller? I need my bubble to be smaller. To do that, I would need a higher pressure. So here, inverse relationships, we got one getting bigger and the other one's getting smaller. Unlike direct, where we had bigger goes bigger. So here my magical number K is 240 times 30, 7,200. Which leads me to the formula for this particular problem. V equals 7,200 over P. So for this particular gas, my K is 7,200. Then if I want to find the pressure, I simply put the volume 160 in here. Go, oh man, I don't like it when the denominator's in, or the denominator's the variable, and the variable's in the denominator. I hate that. Well, just multiply it over. So that goes to 160p. And divide by 160. And you get a pressure of 45. And the pressure was in kilograms per centimeter squared. Like the units to be added when you're talking about a word problem. Okay, some straightforward problems out of the book. They give you a set of coordinates. So here I got 6, 2. That tells me that y equals k over x, so it would be 2 equals k over 6. And again, I would just assume you know that 6 times 2 is 12. You should be able to get that k is 12 by knowing that, hey, x times y is what k is. So we got y equals 12 over x. That would be an equation for this scenario. Then I plug in the 14. And I get y equals 6 over 7. I want to try the next one on your own. We'll pause and check. 3 times 12 is 36. So k is 36. So y equals 36 over x. This one I give you y is 5. Multiply the x over. And then divide by 5. And you can leave it like that. X would be 36/5. You might have noticed by now that an equation that's the exact same as this is x equals 36 over y. That's kind of cool. Your inverse relationship. If y is 36 over x, then x is 36 over y. And then finally, last page here, we got what's called joint variation. And that's simply direct variation, only you're multiplying more than once. And I made a change in your notes. I wrote this to jointly here. Change it to jointly. So it says area of a triangle varies jointly with its base and height. So area varies is equals k. Jointly means multiply, but because there's 2 things, I'm multiplying by 2 things, base and height. That'd be my equation. I did a follow-up. What's that magical number k in this one? Well, hopefully you recognize that k would be a half because that's the formula for a triangle. Area equals a half BH. Lastly, combined is when you put more than one together here. You might have direct with inverse or joint with inverse. I got the electrical resistance of a wire. That's resistance. Varies is equals K. Direct is multiply. And it says with its length. And then inversely is divide. So put this whole thing over. The square of its diameter. Now careful, some people put square root of d, but it's actually d squared. So there's my generic formula. Then I'm going to plug in. It says the length is 200. The diameter is 1/4 of an inch. Got to square that. And the resistance is 20. I'm going to solve for K. Solve for K. I'm going to do 20 times 0.25 squared. And then I'm going to divide by 200. That'll give me K. Multiply those, and then divide by 200. And if you do that, you get 1 over 160, which is 0.00625. So my equation is actually R equals 0.00625 L over D squared. So that would be an equation. Then I say, what's the resistance if it's a 500-inch wire? So just use your formula here. So R equals 0.00625. It's a 500-inch wire, and then it tells you that the diameter is the same. So you dump that into your calculator, and you find out the resistance is 50 ohms. And answer your word problem with units. That concludes section 8.1. Thanks for watching. Have a great day.